All right, we're back. And we should be live and should be good. You guys can hear us now.
Probably in an echo.
No, there's no. Well, first off, welcome back. Issue fixed, but tonight we're going to go through a couple things. It's a whiteboard session, so I think you guys will be happy about that. And we're going to be covering a couple things that I have not seen covered, kind of in the, I would call it the BBT way, where we try to just break it down simplistic on like how wallets work, how the just the transactional nature between the blockchain works, and just kind of walk you through some actual, you know, driving through some of that detail. We should it should be catching up on the video now, and you guys should be able to see me, and we'll go ahead and get started here. So the first thing we're going to go through first is actually wallets, and of course I grabbed a pen that doesn't look like it's going to work very well here. So that one over there. So first thing we're going to go through is wallets. Second thing we're going to go through is blockchain. And just the transactional nature of actually how things work on the blockchain. But this wallet piece that we're going to go through really kind of breaks down into full clients, light clients, and hardware. And we're going to go through, and I'm going to kind of break down the real difference on all of those and make sure you guys can see that, which looks like I'm a little above.
Zoom out a little bit.
Yeah, I'm going to zoom out just a hair. That way you guys can see that. And kind of go through, you know, full light and hardware, and then really how the wallets interact on a blockchain. And I'll make sure I got my trusty wipes here so we can get through this piece here, and then kind of go through it and explain it. The kind of the way I explain when I do a lot of sessions, kind of, I wouldn't call it in private, but just around the group that we're around here, and if I go out and I talk locally, kind of take you through what I usually talk people through, just to try to, I mean, we're talking, this video is going to be really targeted, probably not for your enthusiast, you know, nerd that's hanging out and already knows a lot about Bitcoin and how it mechanics. This is for like your mother, your father, the folks that really, you know, are wanting to get into Bitcoin, buy one, hold it, store it, you know, like the mechanics behind it. So that's where I'm really kind of targeting this video. We'll put some timestamps for some very specific stuff, but just the kind of articulation that I've went through over time of just understanding it myself of how it works, and then really kind of what the differences are. So if we go back to just wallets in general, and mind you, this is not just Bitcoin. This I'm going to talk very abstractly. This is kind of crypto agnostic. So we're talking, this could apply for Ethereum, this could apply for Ubiq, this could apply to a lot of the hardware, just to all the wallets in general. The transactional nature of the way the blockchains work on these different coins act a little differently, and we're not going to get directly down into that level just yet. We're going to just talk mechanically, what are the parts of the wallet, how does it work, why do the address changes, all that kind of stuff. That way you guys have an idea of what is going on with that. So essentially, if we go through, let's look at the just different types of wallets. If you were to go out to like Bitcoin, or you Google Bitcoin and say Bitcoin wallet, you get kind of presented a couple options. You have to where you can run a full node wallet, which is like Bitcoin Core. And all that really means is says that essentially you're going to download the entire blockchain. You're going to host it on your computer. It's, you know, at one point it was like 17 gigs. I think it's a lot higher than that now. And with that, you're going to get an attached wallet that has a series of addresses assigned to it, and that becomes your wallet. And in that, you have a public address. You have many public addresses, but you have that public address with its associated private key. and or private seed. So these are the kind of basic, on a full node wallet, you have the entire blockchain, you're hosting it up, you're connected, you're sending and receiving transactions, you know, you're actually hosting that entire blockchain, that you're a copy of that entire blockchain. That's a full node. That's on a PC or a Mac computer. You download that whole thing and you're hosting it. That's it. The public key and the private keys that come with that would go into a lite wallet, a hardware wallet, all that stuff. These kind of are the basic building block components that are part of that wallet. So full nodes are the whole thing. I don't really recommend, if you do not need a full node wallet. You're more than welcome to download a full node wallet, but it's going to use a lot of space. It's going to make a lot of connections, and it's one that you're not always going to want to keep running and all that, because it'll just sit there, not necessarily saturate your network connection, but it's going to use a little bit of bandwidth as it's uploading and sending and receiving transaction data and helping, kind of like BitTorrent, to where it's sitting there updating other folks that are connected. You become another connection out there in the hive, essentially, for folks hosting up. And I'm using Bitcoin Core as an example, but if you were to use one of the alt currencies, kind of like Chaincoin or any of the other alt currencies that are out there, I'm just picking on whatever, that have full nodes, you would download their entire blockchain. Like I just did it for Music Coin, to be as an example, because I wanted to run a full Music Coin node, so I went and downloaded that. So your main components, again, your private and your public key, which the private address is what you're sending, or what you're exposing to people to have stuff sent to you, and then your private keys are essentially your keys to that wallet. And I'm going to break this down a little more because I think people get kind of confused. Like I've explained this to a few people, and I've noticed when I'm talking about, yeah, you got to make sure you have your private keys, and they're just like, yeah, cool. And I'm like, you really don't, like, then we'll go talk about a wallet. Or like, hey, you know, we need to import your Bitcoin Cash, and they're like, oh yeah, where's that at again? You know, and you can tell that the average Joe kind of struggles with the concept of what public and private keys, and why do they have multiple addresses when they open up their Jaxx Wallet or whatever like that, which is different than a full node wallet. But you know, that's what really kind of drove me to kind of start this explanation here. So, you know, I just talked about a full client, a full node client that you can download, and that's really the only difference. You have your private, your public key, and you have the full blockchain of that particular network. Like a lite client, like on a, let's say a mobile wallet, a lite client would be like Jaxx. You're not downloading that whole chain for Bitcoin. You're essentially just making a connection out to the blockchain in general, and it's assigning you a new wallet, and you do that against a seed, which has a private key associated to it, master private key there. The seed is just like, it's a collection of words, 12 to 24 words, depending what wallet you use, that it uses to generate the pool of addresses that's assigned to that seed. Just think of it kind of like an algorithm. That's just that the collection of those words give you the keys to a pool of addresses. And you're probably thinking, I hate this concept of pool of addresses. Why do I have a whole bunch of different addresses? And the part that really confuses people with that is really genuinely not understanding kind of the way, like I'm going to use Bitcoin again as an example, to where it's kind of like change. You have to have part of the security. And part of the way cash works is to have change. So you gotta, what's going on? Oh, nice. My correction there from the wife jumping in. Having, the way these addresses work here is you gotta have your change addresses. And what that ends up doing is like when you're, and mind you, I'm kind of getting a little off topic here, but I want to explain things here to folks. When it comes to when you're sending something to somebody, you're A, if you were just to send it to B, and let's say you had $100 in here, equivalent of Bitcoin, you need to have, and you're wanting to send 80 here, it's actually making that transaction of that 100 and then sending back that change of 20. Okay? So from a security standpoint, it uses this pools of addresses to say, you know, hey, you sent it from this one, but your change one is going to be here. It's address number 2. That's part of your pool. It's random, you know, and it's really kind of 3 different parts. You got essentially, you got kind of a single address situation, and then you got kind of a deterministic pool of addresses it could come back to and give you your change. Now we'll get, if this kind of use case and understanding that you really want to appreciate and understand a little more thoroughly, we can dive down into this this could be its own episode to walk through various situations of how that works, not just in Bitcoin but other kind of currencies too, about when you're sending and you're receiving and you're trying to understand, like, it came from this address, I saw the transaction go here to the person that I sent it to, but there's these other transactions, and then it got refilled back in here, and now my Bitcoin's in another address in Jaxx, and I don't understand it. And what that comes down to is this whole action here, A, B to C. And as far as the transaction looks on the network, it looks like you sent it to B and C and you were A, right? And there's a few examples of this out on the internet, you know, of like how that particular function works. But if somebody was trying to look at these transactions, they wouldn't know who this, you know, was did you send them 20? Or was it to this guy that's 80? You know, and it's kind of the way change works, right? And change, what I mean by, like, if you had $100 and you were splitting change with a retailer, they would give you 20 back. They have to make another transaction back to you. So if you just think of that mechanically, how many actions just happened there? You have $100, you hand it to somebody, there's one transaction, they split that and hand you back 20. That's a return transaction, right? So just think of it like mechanically, that's what's going on, and they had to account for that mechanically, but then also shroud it in some kind of level of anonymity to have some kind of, you know, some protections there. While Bitcoin is not fully anonymous, you know, from, like, your addresses are visible, your accounts are visible, but the who, think of it like from a database standpoint, ID of who, address, amount. These two are on the ledger. You see that all day long. You can go out to bitcoin.info and you can see all the, and you could go to etherscan.io, you could see all those transactions out there. You don't know who they are, and actually it's kind of fun sometimes. You're sitting there with your friends, you're just clicking through transactions, you're like, man, somebody just sent like $20,000, you know, just like it's nothing, right? But you don't know who, right? And you don't know if that was all the 20. Was it all 20? Was it 10 and they got the return change of 10? So that kind of gets into the kind of concept of that distributed ledger where you can have something so public, but yet still kind of have some protection and identity. And that's why it's really hard, like if somebody steals somebody's coins and stuff, when the people that sit there and go and look and expose, they're essentially, let me kind of blow through this part here. And I'm kind of going on a tangent, but I want you to understand on how kind of the transaction side works, and then we'll get back into kind of the wallet piece here. That you understand, like when they're going through and they're splitting it, these things are splitting kind of like this, and you get these kind of, where are all these different transactions happening? And you got people that sit there and monitor that and kind of look and say, well, I think this is it, and here's all the unique addresses that they're going to. And they're kind of stair-stepping that back to try to figure out just from an address level. And then if they say, hey, I ID'd this because they went to Amazon, or they went to Newegg because Newegg accepts Bitcoin, and I now have a master file from the, you know, the DBA of that, the person that's doing business as, or the person that made that transaction there was that ID. They can start to kind of create a tree of connections that then exposes, you know, who that is, right? So there is ways to kind of reverse it. if you have enough exposure to those addresses, but just mechanically, that's kind of how and why you see some of that stuff. But let's get back to wallets in general. And let's look at, you know, we talked kind of full node, light node, which would be like a Jaxx, and like a, and then like a hardware wallet. And I got it.
Just prove to them that you own one.
Well, yeah, so it's fine. It doesn't. Sometimes it doesn't work always. I'm gonna really have to edit this one when I go back, cause. So if we go back, full node, light, and hardware wallets, which I'll explain in a second here. Jaxx would be under there. Full node would be like Bitcoin Core. Hardware would be like Trezor. I'm going to call it Trez. Right, so those are the wallets. Then all of those will have public keys, private keys, P&P, right? No differences there. Seeds that make up the list of those, right? Same, right? So you're importing that. So the private keys that you want to protect, that you want to store and get into, you know, some other. I just saw somebody that had said that they lost, you know, like $50,000 in their Bitcoin because they had created, you know, they had a full node and then they printed a paper wallet and then they had copies on a USB stick of their wallet and seed, and they were all next to each other and they all burned up. And this private key is the most important thing that you can absolutely secure and keep and hold out of any wallet that you have. Like even if you have a Trezor, what if you lose this hardware wallet, right? You're still going to want to make sure that you have your private keys somewhere, right? So printing a paper wallet is fine. I'd say laminate it, go put it in a bank, get it somewhere else that you know is secure, and then on that paper wallet, it's going to have that public and it's going to have that private key. You can encrypt a local, your wallet.dat. If you have a full client, on this Jaxx one, you'll get the seed, which are your words. And as long as you have those words somewhere, you can always restore that wallet. What's that?
Right bigger.
Oh, right bigger. Okay. Yeah, you could just tell me. And I'm realizing that, so I'm going to give you guys this live stream, and then I'll come back and have something that's more edited and everything, since we've gotten a lot of just questions and interruptions and stuff. So we'll do something that's more cohesive, you know, in this. But this, I wanted to make sure that I was exposing this to you guys, and then we could ask questions live, because I know you want to ask a lot of questions, which will help refine a more dedicated, clear and concise 7 to 10 minute video. But I want to make sure that you guys have a basic understanding of this, of why that's important to have, you know, to make sure that you're securing, that you have your paper wallets, and that you keep your seeds. You know, you get the seeds to your wallets somewhere else. And, you know, the way I explain it usually to people locally is I'm like, you got to think of like your private key, like you have a lockbox, and that box is your wallet, and your contents in that box. The private key is the key that gets you into that box. And that's what you want to have copies of, and you want to put them somewhere where you always can get back into that box, right? If you have like a hosted wallet, and this is why when we start talking wallets and everything I've been talking about is stuff that you control, that you have the keys to. The reason, like exchanges, you're like, well, why don't I have private keys for my exchange? You can think of the private key for the exchange as you just have a key to get into that wallet. That's not a master key. It's like if you go to a bank and you have a safety deposit box, you get a key to that safety deposit box, but they have the master key, right? Equivalent to this would be just like a watch wallet or a watch key. You have enough to where you can get in there, you take the box out, you can get in there and kind of make changes and stuff to it, but you can't take the box out of the place, and you don't own that box. That wallet, in this analogy, that wallet is that box. And in exchanges, you don't have those original private keys. So you can't go reinstantiate that box somewhere else. That's why moving it out to where you own the master keys is critical if you want to have and retain control of your wallets all the time. Because a lot of people ask me, they're like, hey, why, I can get into my wallet on an exchange. I don't get why I can't have the private keys. And some exchanges they keep kind of a hot wallet that's actually on an actual blockchain, and then some are just, when you're going in and interacting, you're not necessarily interacting with that particular area that has your particular quote unquote coins. When you send a from your wallet local and you send that to an exchange wallet, it goes into their hot wallet. But they only keep so much in their hot wallet. So they'll take your coins and move it into cold storage, and then just this relative amount that they have in the exchange, they're interacting with you. So you just have a reference assigned when you're on your dashboard, like in Coinbase, you just have a reference to the fact of how much you have. You're no more than a database entry at that point. So when you go and interact with stuff, just whatever's in this hot wallet is what you're getting out. Like they have to do actions to pull, if they start running a deficit, or they get close to running a deficit, then they have to light up some other wallet. They have to do some exchanges on these different cold storage wallets that they have to pull in and fill up that hot wallet on an exchange. So you don't have keys to this necessarily. These keys again are like a seed to a single wallet. When you see some of the exchange wallets that are out on the blockchain, and you see all these thousands of Bitcoin in there, tons of thousands of Bitcoin in there, that's a single seed that's on that single wallet on that. So they can't give you keys to that wallet because that's like their wallet, right? So just that way you kind of have a basic understanding on how those wallet pieces work. So again, we went through, make sure I got the lite. So full client, light client, hardware wallets. People are asked why hardware wallets. Well, hardware wallets, they're one of the most secure because nothing can be written onto that hardware wallet. If you have a Trezor, and that like a little USB stick thing that you can actually plug in, that has it to where you can have your private key on there and you can sign transactions, and nothing can compromise. Well, I mean, nothing to date has compromised that because it can't have it. It's essentially a read-only ROM that is not compromisable. To where, like, if you have a lite wallet, we'll pick on Ethereum for a second. If you have like MetaMask or something that's in your browser, having some kind of and you go to look. Let's say your computer's compromised. You go in to print a paper wallet because you're like, oh, I haven't printed a paper wallet yet. Your computer's been compromised. The second you go and expose those keys, you could have a mischievous piece of software on your computer, and now you've exposed yourself. These hardware wallets, you can't get that bad software on that hardware wallet. That's why a lot of people recommend those to have and store your keys on a hardware wallet. But again, like, I'm super forgetful sometimes and I lose stuff all the time. So that's why I'm super nervous about having, now granted, this private key that's on this wallet, was probably created at some point from a full node or a lite wallet, like a Jaxx wallet, and I just imported those private keys, right? Well, this will come with one that you can send to, but, and I'm actually talking about a particular situation I've done with two clients where we've done like an offline situation, not the Trezor, but because you can send your money over there, you own those keys that are on there, because those are the only keys on there. But if you had a Jaxx wallet, and as long as you have your private key, you can take that anywhere. A private key is a private key is a private key. As long as you have your private key and import your seed, you're good. But the big thing is that's why that's important to always have, because you can always reinstantiate that. So let's see here. So we went through those, went through the seeds there. You know, there's like an entire episode I could go through to explain like the whole multi-address issue, because there's essentially three things. There's you know, single addresses, which you always have. You know, it's the same address. It's like the one you probably send your pool information to if you're mining. And that address always receives. That's your receive address, and that doesn't change. And then you got like your random pool of addresses, which you'll see in Jaxx. Like if you go into, and I'm using Jaxx as a mobile wallet because I use a mobile wallet for Jaxx. And you can go in there and you can see all the different associated addresses that it's created to date in there, and all their associated direct private keys to those particular addresses. And then you have like your seed, which doesn't change because that seed is what connects you to all your different pooled addresses. And then, you know, if you have a local wallet, what's up?
They're asking for clarification on a paper wallet.
Mm-hmm.
Is a paper wallet something specific, or is it just when you print out your seed? Or
so you could have a paper wallet. A paper wallet could be just printing out your, yeah, you could print out your seed because you can restore that wallet. The original paper wallets always had a public address. Like if you look at it, they kind of made it look like currency, and it had a QR code. And then it would have public address, private address, right? And you could store that as a piece of paper, laminate it, go put it in a bank. And if the computer that generated this, so once you have this public address, and let's say you transfer, you bought Bitcoin off of Bitcoin or Ethereum or Ubiq, it doesn't matter. This concept is the same, public and private address. Let's say you went out to Coinbase, you connected your accounts to Coinbase, your bank account, you bought, let's say, 4 Bitcoins or whatever. Coinbase's addresses, your wallet is out here. You transfer it to this public address. So now let's say this thing has 2 full Bitcoin on it. You can delete that, once you print this off, you could delete that local wallet, right? You transferred your stuff out of there. It's on this, let's say it's on your computer, and then you can nuke the instance on your computer. You can completely take it offline. Because you can go out and say, you know, I sent two coins to this address, and I can go out on the blockchain and I can see that those 2 coins are sitting on there. And I want to take it offline. So now it's offline. I've deleted the instance that was on my computer, but I can always restore it because I have this private key to where if I ever needed to reinstantiate it, I could install, you know, a local, like an Electrum wallet from Bitcoin, and I can do their existing wallet. I can import this private key. And the same thing works with the seed. So if you started it and you got a seed, which is just a pool of addresses, not just a single, it's just not, the seed is like the pool of addresses that's associated with that algorithm that's with that seed. So if you have a seed, when you go, let's say you download it like an Electrum wallet, you created a Bitcoin address, the first thing it's going to pop up and say, here's the seed for that address, or for this wallet, which is just a pool of addresses that's associated to that seed, right? Or deterministic pool of addresses. So you may have, you know, X amount of addresses that are associated to that seed. So the first one that you look at when you first go into your wallet, you're going to have the first address. That if you had, let's say, you went out and bought Bitcoin from an ATM, you're essentially going to get a slip of paper that says, here's your Bitcoin, it's on this address, here's the private key associated to it. You could then take that and consume that wallet into like Electrum, and then transfer it over to your other Bitcoin address, your first Bitcoin address that's part of that new seed that you just created, which is essentially just this bucket of, this wallet, which has a bucket of addresses. And then from that, use that function to print your paper wallet, and then delete this off your computer because you have your seed and the associated private key to it. But the seed, you can import it from the seed. The seed was like kind of like an evolution of just when you first, like in 2010 Bitcoin, you essentially just had your private keys. But the way Bitcoin the way Bitcoin acting as cash, and you have multiple addresses, instead of just trying to do a single address that you're always sending and receiving to. Because once that single address, if you like certain software, you can have it to where the ID is that first public address that you have, and everything comes back and forth to that address. You can get it set up to where you're just doing that. But once you're ID'd, all your transaction history is public in ledger. So folks that like us, like we have donation on all of our videos, right? We have a donation. Most of the people that are in the crypto space have like a donation thing. It's just kind of one of those things that everybody does to say, hey, we're dropping information. You guys are, if somebody sees this and sees it valuable, and like here's a 5 spot or something, right? That address never changes. Anybody can go out there and you can see what the total Bitcoin that's ever been sent over to that particular address. And you know, because I've exposed it, that that's my address. So you know that public address, that anything there is, that one is pretty self-explanatory. You know that person's address, right? Every video, rarely do you have somebody going in there and just changing that all the time. Oh, there's my ID today, there's my next ID, They don't necessarily do that, but because it's kind of a waste of time. Because essentially, well, I know those are all yours, and I don't know why you're taking the time to change them all, right? So, but when you have a seed, you can keep generating. The confusion part was like, hey, I downloaded a wallet, and it lets me create all these addresses. How do I keep track of all those addresses, right? Well, you keep track of all those addresses based on that seed. That seed is deterministically letting you create multiple addresses under that same seed. So then if you were to import this seed into a new fresh wallet, you would have all of those addresses that you've done so far since then and the associated private key to those. It's just a deterministic connection. Think of it like an algorithm that allows you to bind back at any point in time back to the blockchain. Because understand that all of this stuff here, none of this is actually on your computer. None of it's actually there. It's actually just pointers. And what I mean by a pointer is it's just pointing back to the actual public blockchain. Like all this stuff just points right back and just reassociates your connection to the public chain.
So just to clarify, the private key is only to access your wallet. If you are sending or receiving, they will give you different addresses for that. That you don't send a private key. Someone was saying their private key to when they're purchasing or giving money to someone.
You never do anything with a private key. It's all
private key is only for you.
Only for you. It's your keys to the cage. It's just the private key is associated to an address. You're essentially signing that transaction. You're interacting to say I allow that box to be open and money to be taken out, and then that box is closed. But you're the one that owns that key, right? Or you've asked for an initiation for somebody else on your behalf to do that, like from a Coinbase or something like that, where you don't own the private key, but you're soliciting an interaction, and you've given a key but it's like an internal key to say, hey, I want that to happen. It's kind of like a multi-signature thing where it's like, hey, I want that to happen, and then they go initiate that connection and do that. And that's not to be confused with like, there's other layers of wallet where you can have like a situation where you have like two computers, one that's offline, one that's online, and you have essentially a watch address, and you sign everything with the offline computer. You can put a USB into it, you know, accept the send a transaction, and it'll say, okay, go sign that, and then you can go over here, USB stick it, sign the transaction offline, and then come back here and do it. That way you can kind of control. This kind of usual scenario isn't like for like your mom and pop, right? They're not going to do that. You know, they're going to probably use Coinbase. They're going to use something else that's kind of a you know, segregating that over to letting somebody else handle that business, but understanding that, or you know, having a hardware wallet or something like that, and not to also be confused with multi-signature wallets, which means that you're essentially setting up a keychain to say, I want to send X transaction, and you got to get signature authority. You got 3 people got to sign it or something like that. There's like some kind of, there's a like a business process that's in there to say, yep, okay, let that go, transaction-wise. You got those situations too. Both of those are kind of, I would call them edge cases on wallets and transaction stuff. With the average user is probably not going to do any of that. And that's where this kind of video is, just to let you understand like how, you know, how the private key and how the importing back and why getting it to like a paper or having an example that you can always re-import is a thing.
So private keys for your wallet, you will only get one, but you can get multiple public keys to send to other people.
Hundreds of addresses, yes, correct.
But private, you will only ever get one for your wallet.
So you get your single private key for your wallet. When you dump your private key out, that's your private key. Your for that series of addresses, like on Jaxx, I've had a couple different private keys before when I've exported out, but that's because that wallet was on a different phone, right? It created a different mnemonic key for that other phone. Like I had imported another wallet, I went and dumped that out, and then it had split that actually into 2 separate wallets, and I had 2 separate private keys for it. So you can get into some situations that, like when you've imported, and that really comes down to from the way Jaxx software handles creating keys. Between like iOS and Android phones, like where it supported a whole bunch of other ERC20 coins. But your seed, a lot of people are kind of getting away from as long as you keep your seed, you can still reinstantiate those wallets. You can import your seeds. And if you look at all the newer, like MetaMask, Ethereum, all those, like for Ubiq, you know, you can get your wallet seed, and you can go and import it by seed. You can import it by a private key. All right, so if we get in to, so if we understand the kind of basics of the way the wallet work, the way essentially here, let's go on to blockchain. So, you know, one of the first things, and most people already know this, like all the transactions on the blockchain are irreversible. You send a transaction, there's no takes back keys. So this is more like everybody that understands this technology, by and large, knows that. But for the new folks that are looking at there, when you send this is one of the I would call it the value propositions of blockchain in general, especially if you're like somebody that's ever had to deal with chargebacks. So no takes back keys, no take back. That's why, like, if you're doing any kind of internet purchasing, or let's say you're doing something on Craigslist, something that somebody's like, yeah, I'll buy that, and I always tell people, like if I'm buying something on Hardforms or something, hey, I take Bitcoin, I take Ethereum, I'll take any of that, because once I got that, I know that they're not essentially, you know, screwing somebody over, right? That's part of the benefits of blockchain, is that there's no take back keys on that. So you kind of create this separate aura of reputation, because like if you keep screwing people over, then nobody's going to send you Bitcoin, right? So you kind of have this innate reputation system that's kind of built off of that. And I can see that over a long period of time as people start to get more comfortable and get kind of away from PayPal and other means of transactions, that there's a lot of good open space to get good improvements on these kind of systems, like for forums and everything else. I mean, there's Heatware, which is a forum kind of like system that's out there. It's kind of like on eBay, if you had like feedback, like reviews and stuff like that. Heatware is one of those kind of reputation systems that if you're kind of doing stuff with like Bitcoin, or you're taking transactions and stuff, that you can see if somebody's like legit. Because once you send that to them, it's gone. There's no getting back. And then essentially, I already kind of talked about the three main components of all the transactions. And this works a lot with Ethereum and the other blockchains too, is essentially you have your ID, which is hidden. People don't know who you are. And then you have the address, and you have the transaction amount. This stuff's exposed. Your address, that's exposed, and your transaction amount is exposed. And your ID on the blockchain is hidden. They don't know who you are. They just see an address, right? And over time, I can see more and more people that are going to create blockchain. And you can sign and add information to say, hey, I'm this person. You'll see that on some of the transactions that go through the blockchain infos, if it's a particular pool, or if it's Satoshi Dice or something like that, where they've tagged the transaction ID to say, hey, we are X, we are Poloni X, that's who we are. So you'll see more and more entities popping up that are going to start trying to correlate addresses to people, right? There's a whole service that's probably in the background that's being created by people right now to go and start mapping IDs to addresses. Now it's it's an unfruitful effort in the long run, I think personally, because if people figure out that, like, well, I don't want somebody to know, I just want to keep my transactions private. You wouldn't expose your bank account to everybody, right? So, people could just use different addresses and just not make sure that they're exposing that particular one or whatever. So over time, I think that'll kind of work its way out. But there's the basic functions. Again, I'm kind of going down into for some of you folks who know that, like, hey, this is obvious stuff, but there's a lot of people. I cannot tell you how many people I start having a conversation, because with Bitcoin's highs and with the way cryptocurrency is right now, a lot more people are interested in it, and they ask very, very basic questions. And unfortunately, I can't tell them, hey, go check out my videos, because I usually don't talk about this. We're really about mining and all that kind of stuff. So kind of just talking about the basic mechanics of what's in there. And this would be on any of your blockchain explorers. Blockchain info, .info for Bitcoin, etherscan.io, Ubiq Explorer. There's all kinds of pretty much every chain that's out there has some kind of explorer that's essentially showing all this transaction in and out stuff. So mechanically, that's that. And then, so what happens when you're sitting there sending stuff for people, and why does it take, like, for instance, I can't tell you how many people send us messages like, hey, what's going on with my Bitcoin Cash? I was able to restore my private key to my new wallet. I have my stuff. This is like 2 days ago, right? I see it. I see the Bitcoin Cash, and now the exchanges are about to open. Why is it taking so long? Why is it just not? I thought this stuff was fast. I thought, like Bitcoin Cash was going to be faster. And it's really just people trying to understand, like, how the blockchain works in general. And this is going to be a broad stroke across not just, Bitcoin. It's also going to cover some of Ethereum. I'll pick on Ubiq a little bit too, and how the mechanics work and kind of in the background. So I'm kind of jumping around a little bit, but I want to make sure you guys have an understanding of this. So in Bitcoin Cash's situation, when the chain forked, right here, if this is BTC and this is BCH, Bitcoin Cash, it inherited the difficulty that Bitcoin had, which is how all the blockchains target the complexity. The blockchains that have proof of work, which means that people that are mining it, they have essentially a calculation step that's there that looks how difficult it is to mine the next block. So if Bitcoin's set to 10 minutes intervals to write blocks, that function, the block function, is doing really two kind of, I'm really simplifying this, but it's doing really kind of two things. It's posting transaction ledger updates. So if you've done something, it actually posts it to the ledger that all the miners agree with. So, and then it's doing that distribution of currency. So each block for Bitcoin is 12.5. This was going to do the same thing, but the transaction that's happening between blocks. So if you send something on that network, let's say you're not even sending it to an exchange, like you had a buddy and you're like, you know what, you owe me, and I'm like, you know what, I'm going to send you my Bitcoin Cash because I owe you $100. I'll send you $100 in Bitcoin Cash. I just got some free money, right? So they're going to send that, and what's going to happen is that action is going to happen almost immediately. He's going to send it, and then it's going to sit there with 0 confirmations. And then it's going to start working its way up as the miners start to pick up those transactions, but nothing will be posted in this ledger until the next block, provided that the transaction that occurred between you and your friend, provided between those two blocks, that the mempool, which is all the different transactions, think of all the transactions that are going on between people, that start getting confirmed, confirmations start as quick as a miner can pick it up. You could end up having 5 confirmations, but you're not posted in this ledger yet. That's why a lot of the blockchains, and since this inherited the difficulty from Bitcoin and only brought in like 5%, its block times were like 3 hours to, I think, somebody can correct us if we're wrong, I think it went as high as almost 11 hours, where this is 10 minutes. So you had all these transactions queuing up and nothing that was posting. And an exchange is going to want to see posted transactions. Now there's a math problem here that they can say, you know what, there's been 20 confirmations, and that's really kind of where I believe Bitrex actually came in and said, you know what, as long as we have 20 confirmations, we're good. We'll go ahead and post it, even if it's not part of this block yet. We have confidence in the math and consensus and the whole way everything works, that as long as there's 20, we're good. And now if it's your friend and you see them send that to you and it says transaction pending, no confirmations, you're probably pretty good. It's your friend, you've seen the mechanics happen, and you know that there's probably no funny business going on between that. But if somebody doesn't know you and doesn't know the situation and they're going to do some commerce with you, they're going to want to wait for at least some of the transactions. They don't necessarily need to wait for it to be posted in that next block. But they're going to wait and see how many confirmations, how many of independent miners have confirmed that the math has occurred, that things has actually transacted, you know, with regards to confirming the debit and the credit there, right? That's essentially what the actions that are happening in between the blocks, right? This is the posting of those transactions to the ledger. That's the difference. I mean, that's a fundamental difference between when people are getting confused, like, well, I see all the confirmations, it's just not posted in that next block, right? So that's why all those transactions, well, and that's why you had issues where these block sizes for like Bitcoin before the segregated witness and all that other stuff was filling up. You know, if you had a 1 megabit block, all those transactions are getting full, right? So you could have tons of confirmations, but you know, there was a period of time where you know, maybe 3 blocks would have happened before your transaction got put into the next block, right? So 30, 40, 80 minutes, whatever. It's just whatever it was filled, however full that mempool came with all those different transaction IDs that were happening, and they all had confirmation. When is it going to be in that next block? So that's part of that. That's part of the whole, you know, Bitcoin Cash went to 8 meg blocks. You know, and Bitcoin has a different, and I'm not going to get into trying to explain segregated witness to you guys right now. I mean, not in this video, but you know, it's made adjustments in there to facilitate a faster transaction, you know, network in general. But that's essentially the mechanics behind it, and the reason why the exchanges, you know, just didn't open the doors right away and allow people to get in there is because of the heavy block time. They needed to validate and make sure that there was no, you know, when they had this where the block speed here got to a certain point and the blocks here were way behind it. Right? It's just a math problem. How many blocks per hour? There's 6. It's on the average of 10-minute blocks for Bitcoin. There's 6 blocks an hour that you usually chew through. When they're going 4 and 5 hours without having 1 block, they're getting way behind. Right? Like in 2 hours, if they've only done 1 block, they're already 12 blocks behind, or 11 blocks behind in that situation. Right? So that's the real the discrepancy. Now, so that's I just talked Bitcoin. Ethereum is kind of in the same boat with the increases of difficulty that's being done artificially, right? So right now with the code that's in Ethereum, and if you've looked at the block, difficulty right now, it's went up exponentially. You know, just on August 1st, it was 1,200 terahash of difficulty. It's at like, well, it went down to 15 something, but it went up to like 1606 terahash of difficulty, where the network hash power is somewhere down here, right? Well, it's probably a little higher than that. I'm being a normal miner, bitching. So it's more like right here, right? So what happens is because it's not being predicated on the mining, there's a gap here. What's happened here is the Ethereum network should be 15 seconds block time, and right now it's like 20-something seconds, because there's a discrepancy between the artificial push of the difficulty, which this feature was the difficult bomb, was put in play because effectively Ethereum was supposed to be going to proof of stake, and they were trying to de-incentivize people from mining it. So this thing would just keep up going up exponentially and make it to where it was like highly unprofitable to mine, and then they could switch over to proof of stake, because when they go to do a proof of stake, they got to hard fork it. And when they hard fork it, the last thing they want to do is have like a Bitcoin Cash situation to where people are like, you know what, good luck, I'm going to just keep mining. Because when they go to do a hard fork, because the software has to change in such a way that they gotta make a hard fork change. And what they want is, if this was the miner path of mining, and this is POS, what they want is that it's so not good to keep mining it that everybody kind of just says, you know what, we agree, and we're going to go down this path. So since they've delayed this, they need to answer the rise in difficulty to be more in line with actual hash power. Because this thing's going to keep, it's like, I think it retargets like every 7 days or something like that, 14 days. And the next time it goes up, again, it's gonna get really close. If the price stays pretty constant, it's gonna get to the point to where it's like, as a miner, as a person doing it, I'd rather put my efforts on something that might be more fruitful, potentially more fruitful. And most people will start to too, right? Something that's going to have more of an output, a yield. It's more incentivized to go, maybe go mine Ubiq or some other. I keep saying Ubiq, but I mean it's you know, if you got Monero, you got Zcash, you got Expanse, you got a lot of other coins out there that there's opportunities to mine. So they're going to have to adjust this difficulty to be more in line with this until, if they have an 18-month plan to get back onto POS, and then re-engage that proof of stake time bomb later on in the game. And price and all that should adjust accordingly. I mean, it's just part of market dynamics. Without any of that stuff being messed with before, price did what it did. So that's essentially the kind of mechanics of, like of a hard fork. So if you have a majority of hash power in proof of work during like a hard fork situation, you can split that coin. Right? So that's kind of the background on that. And then we kind of went through confirmation structures. I wanted to kind of explain that between the blocks of why you see some. I mean, some of these exchanges that have like 50 confirmations. I mean, that's just annoying. Part of that's just a delay. There's artificially they can do other things to say, well, we're going to slow the roll of income into the exchange because it also will slow down like the arbitration side of it. So if you have exchanges at different rates of stuff, they can see an inflow because they're confirming, like let's say 50 or 50 transactions between exchanges, they can see that inflow, and it kind of gives, I mean, not saying that they're doing this kind of activity, but if they see a lot coming in and it's starting to confirm, if they're on the exchange, there could be some manipulation that they have control of because they're slow rolling the inbound, right? They have the ability to control the inbound by slow rolling it, saying you need 50 confirmations and stuff. So, after about 6 to 7 confirmations, I mean, by and large, you're pretty good. I mean, that means you got 7 potentially completely different people that are running full nodes that the software agrees with the mathematics that a transaction occurred and nothing was messed with, and it didn't deny it, right? So after about 6, it's usually pretty good, but some of these block times and everything is so fast, and they want to set it to a higher amount. I think I covered most of the stuff. I mean, we could go back. I kind of jumped around, and it was a little discombobulated because I was getting questions and some suggestions because you guys couldn't see because my writing was a little small. One of the other top questions I usually get is like, if I want to store, if I don't feel comfortable printing that piece of paper for a paper wallet, where can I save? You can save that wallet.dat off your computer that's created with whatever coin. Make sure you've encrypted it. And all of encryption means is that most of the softwares that you download, like full clients, that'll give you an option to encrypt. And all that's saying is that it's going to go do a function to lock this up with a password, right? So you're putting a password on a function that's going to take the contents and encrypt them, right? It's a box. Think of the encryption like a box that's just doing stuff with the things that are inside it, and you need a password to get into it. So at a minimum set, you want to encrypt it. Because otherwise, it's like having an Excel file you could just get into. Like they could go and they could parse in that information and figure out, if it's not encrypted, they can get to your coins immediately because they'll just import it. They'll download a full client, delete their wallet.dat, drop yours in there, turn the client on, and bam, there's your stuff, right? And then they can send and receive your own coins out of there. So you got to encrypt your wallets. Now, some people kind of do like a double encryption where they'll take the wallet.dat and they'll use some kind of third-party software to re-encrypt that wallet as the actual file you'll encrypt it, not just the contents in the file. So they'll take this and then they'll add another layer of encryption on top of this to say you can't even read that file, right? And then that's if you're going to like a cloud storage where you've added another level of encryption on top of the actual file. Because when I say encrypting your wallet file, that is that the wallet file itself inside is encrypted. And then you can actually encrypt the actual file itself. That's just adding another level of encryption. If you're putting it on a cloud storage, that's public, or it's not public, but it's just, it's not in your possession. It's somebody else. What if the cloud storage gets compromised and the first thing you left it named wallet.dat and the first thing that they're looking on that compromised thing, it's highly unlikely, but if it did, they had wallet.dat files, now they can get to it, So Other versions of encryptions are taking when you're setting up your wallet, if you're not getting a full client, you're not getting a wallet.dat, you may get just your private key, and you're taking that private key in a text file, and then you're encrypting that text file. Now that doesn't have any built-in function to encrypt the stuff that's inside of it. So you got to do the outside encryption and encrypt that file up. So you're using a third-party program to encrypt that file, and you have essentially another password around that file. You can also do it with a JSON, a .json object, which is essentially just a way for you to import it into other wallets, like Ubiq Coin's Pyrus Chrome wallet. When you're going to create a new wallet, you can actually save all your seed as a JSON object. Then you can encrypt that JSON object. Which, just think of it like a file. Don't worry even about the name. It's just a file you can import. Like if you save that, you sent coins to that address, and then at some point you want to restore that, you would pull it down from your cloud, unencrypt it, and then go in and download the new Chrome, the Chrome add-on, and then you say, instead of a new address, you just say import my JSON, next, type in your password, and now it's reestablished your coins back to you. You know, and I'm kind of just doing this on the whiteboard. If it makes sense and it would help you guys if I do an actual episode type of video that's like 7 to 10 minutes, something like that, and actually just mechanically show you, not just another whiteboard session, will actually just mechanically show you with a few of the different wallets. You know, we can do that and walk you through kind of that understanding. It's just, it's hyper important, especially with, you know, and it almost deserves its own episode of all these different coins, you know, Chain Coin, Ubiq, Ethereum, Monero. Like, let's say from a miner standpoint, you guys have like, oh my God, I got to download another wallet. I got to download another client, you know, that you have to have. And now you have them everywhere. And which wallet file is which wallet file? There is an absolute 100%, and I agree with you, space that somebody could really come in and really simplify that, and they would be awesome. And Jaxx is trying to, from like their mobile wallet, where they're handling a lot of the ERC20 tokens, and they've added some other support for some of the other coins, but nobody's moving at the speed, short of exchanges, to where you could self-manage that really quickly. So you do have to have like the one computer or whatever that has all your wallets, all your addresses, thin client, like, you know, the light clients, you know, like MetaMask for like Ethereum, and Ubiq's Pyrus, you know, for the quick clients, and then you got Signitum and you know, Chaincoin and Music Coin with their own full client wallets, and you got all these wallets out there. But what the best practice that I've seen and what I've done is, on every new coin, is I download whatever wallet. So I have essentially just this wallet, like this temporary computer client that just has like a single 120 gig solid state in it, to where it's just, I test out to make sure, you know, it's got antivirus and all that stuff, to make sure that they're, you know, I'm building as much as I can from source, and we probably almost need to do a video to show people how to build stuff from source. But you know, build that wallet. Get a basic, the first one I call a cold storage. The first wallet I download, I name that cold storage. I get the seed to it, and the address, the first address of that seed, and then I nuke this. I nuke this wallet. And then I download the same thing. So let's just say this is Music Coin. I did this with Music Coin. First wallet that I opened up, I got the seed. I got the address. I copied, pasted it into a notepad. That way I had that address. And then I killed this wallet locally on the computer. I deleted the wallet.dat. I reopened up that Music Coin. It's going to create another wallet right automatically and say, hey, welcome back. You're new. Give me another one. And then I call this one Hot Wallet. And I do not keep a lot of coins in any of those, right? This is going to give you a new seed and another address. And this is where the pool sends the mining proceeds to. And after a certain amount, it gets transferred to this wallet that's no longer on a computer. I have a copy of the seed, and if I ever need to access those coins, I can always reinstantiate it for the time that I need it. But this wallet only keeps, you know, depending on it, 100 USD worth of coins. Roughly. Just whatever I want to interact with. And then a transaction sent over to an offline wallet. Just to keep myself protected. It's not even on, it's not on a Trezor, it's not on a hardware wallet, it's nothing. It's offline. It's completely, essentially a paper wallet. It's still out there on the chain, and I can still send stuff to it, but it's not on a computer. So we do that just for safety reasons across all the coins. Almost literally everything that we do, right? And that practice keeps this offline all the time. And that seed's like the most important thing since sliced bread. You gotta print it, laminate it, nuke any instance that you have. Like if you printed it as like a PDF or anything like that, you need to nuke that. You don't want your seeds at all on your computer. Like nada. I don't even have them like encrypted on a cloud place. That is like a print, lamination, and then to a bank safety deposit box, right? And I mean, yes, can somebody crack into the safety deposit box and steal all the seeds? I mean, yes, somebody can crack into a bank and steal money, right? I mean, so it is what, I mean, and who knows, in some point in time, that's probably going to be bad advice at some point. You know, when if people are criminals and they bust into a bank and they're like, give me all the money and make sure you give me all the safety deposit boxes too, because I know there's a whole bunch of people with crypto wallets in there, right? And then they can import your private keys. I mean, that might be a thing at some point, you know? So there is risk in that, and I mean, I would assume that that we got to weigh that, because nothing is ever 100% safe. All you can do is mitigate, right? And a place that's secure and has cameras and everything else seems to be the best place to put it, right? But having, you know, that kind of strategy to it, and the places that you won't lose that seed is huge, right? That way you can have it and get it back. But do we have any questions? I mean, is this remotely valuable, or was I too far all over?
No, they think it's great.
Okay.
Do you want to keep on this topic, or you want other questions?
We can put timestamps, so I can jump around. I mean, if there's other just genuine questions, we'll take questions for about 10 minutes or something, and
okay.
We'll see.
Can you outline the upcoming changes to Ethereum mining? Is there anything coming down the line in the next 2 months?
I did not see if there was a dev meeting yesterday. I don't think there was, but so they had the last dev meeting notes posted, and we could put them on bitsbytrippin'. Let's write that down. We'll put the last series of notes. So people that don't know, for Ethereum kind of run their dev meetings. So in normal dev world, you have, especially if you're doing something like Scrum, just pretty much means that you're going to have kind of you pull everybody together in a room, you talk about whatever backlog items you're working on. With Ethereum, the backlog items are called EIPs, which are Ethereum Improvement Plans. It's the same as Bitcoin has open BIPs, Bitcoin Improvement Plans. Those are the backlogs items that those backlog items are essentially the punch list of stuff. Those things are published out there. Anybody can go to them. You can actually start looking up, like just Google Ethereum EIP like 649. That's the number 649 is the difficult bomb that I was just talking about. That they're trying to figure out a way to address. It's not really like they can go in and do a soft adjustment, a soft fork, just change some settings and implement it and drop that difficulty, predicate it back onto the hash power. That's honestly what I think they should do. I mean, obviously I'm a miner, and I think that's what I think they should do, that because they had an intention of what that difficulty bomb was for, and it got pushed. So right away at that second, they should have just turned it off. So okay, let's go back to just network hash power, and then let the hash power on the network predicate what price and output and all that stuff is, right? Because that's predictable. But all of those EIPs are out there. The punch list that was out there, they published kind of a roundup of what was remaining on that punch list. These meetings for Ethereum are published on YouTube under the Ethereum Foundation, and under description they kind of give a punch list with timestamps of things that they covered, including which EIPs they covered. So we can make a link to that, and then that should answer that question. It's super public, so you can actually go out there and tell them your disapproval of certain things if you don't like certain things and all that kind of stuff too. So that's the way that kind of functions. And that's the reason why, like, people are like, why Ethereum? Why is it all whatever? And why is it popular and all this? I mean, they're super visible on the stuff that they're doing and some of their decisions, both right and wrong if you have different opinions of things, but they're visible on what they're doing. Bitcoin's a lot like that too. They'll put the BIPs out there and you guys can go out there and look at them too and read them. It's super transparent. And that's the questions that you can come back from, like, any of these other coins like Chaincoin or Ubiq, where are their improvement plans, what are they taking, and looking at their progression of progress. That's a Canadian way of saying it, progress. Anyways, I'm from the Midwest, and it's progress. We got another?
Yes. If you put your Bitcoins in the proper wallet, how do you go about getting your Bitcash?
So, how do you go about getting your Bitcash? So, if you actually had your Bitcoins in a proper wallet, that proper wallet you should be able to go into and look up the seed, which should give you the words that are associated with that, or the private key for that wallet, which would be a long, like 64 character plus key, right? You download a Bitcoin Cash compliant wallet, something like, I think, Electron Cash. Electron Cash is a wallet. Now, if you will use Electrum, they kind of use the same dependencies, and it gets super confusing. So you want to make sure that if you, I do it on a computer, I don't have any other wallets around or anything, but you can download Electron Cash. I think it's like 2.9.0 or something. Why I remember this kind of stuff, I don't know. It just happens. And you go in there, and then you import this seed, which will reestablish your BCH. Because you got to understand, your Bitcoin and your Bitcoin Cash are essentially the same things on two different different fork, essentially. So you're re-importing your Bitcoin that's now considered Bitcoin Cash, because when it's split, if you had 11, you have 11 here. So you're taking that private key from your BTC, you're importing it, or your seed. You're just establishing the Bitcoin Cash wallet, which would be like Electrum Cash wallet, and you're importing that seed, which will then reestablish your BCH. And then you'll have BCH, which you'll be able to then now transmit to an exchange if you want to exchange it, or you can just hold it or whatever else. I mean, it's just whatever you want to do. So you just import that seed into a BCH wallet at bottom line. That's the quickest answer. Did I get it? Got any more?
Ubiq pools. They said prop, or is it PPLNS? Does that make sense?
I mean, that's like the number one question in general of all pools. Which one you're doing. I use hold pool, which I think is prop. I think they're prop. I mean, it's what I say is benchmark it. Here's the problem. It's hard to benchmark. I tell you to benchmark, but benchmark would be like you do it for 24 hours and then you do it for 24 hours. That's great if the difficulty stays the same. But something like Ubiq, the difficulty changes quickly. Like it's auto retargets like after every block or so. Like, so if you have something that the difficulty stays static, essentially, you can easily check to see at least within a margin of error of which one's better for you. But it retargets to difficulty, and as the difficulties go swinging up, and mind you, the reason why it has ups and downs is not always predicated necessarily on price. It's predicated on the other prices of things. And then you have like sites like What to Mine, which tell you, hey, Ubiq right now, this second is the most profitable, and you have this huge swing in hash power that swings over to it, and then it'll come right back down off of it. And so you have these weird kind of elevations and pits of difficulty swings. So I mean, I would say just do a notional test on it week to week and see, hey, in 3 days I earned 26. Just write it down. I mean, the best thing you guys can do, I mean, if not everybody has a whiteboard, is just say, I moved 187 mega hash for 12 hours and it was sustained, and I received 13.2 Ubiq on this thing, and then just do it again to here. And if there's a huge discrepancy between the two, you can see, was there pool? What matters is the pool luck sometimes. If they're real low, 89%, or if they're like 110 on this one. It should be very indicative of like what your output is. If it means that they're just not winning blocks and people are putting effort in there, and essentially they're just getting shares on the pool, and then that's a numerator and denominator division of if they won a block, which is 8 coins, the pool is sharing it based on their percentage of share, right? Of that 8 currency, and then that's essentially your division. It's agnostic to what you should get based on if you had this much hash power and every block was made. Because a lot of these calculators just take the notional average of like, they're not looking at prop or PPLNS. They're not looking at this mechanic. They're looking at like if I have 180 this much mega hash versus the total of the network and the difficulty, you should have this output. But that's not taking necessarily this into account, which is what you would call this as your size of pie of what they should be receiving. What are they getting? And of that, what's getting divided essentially between the people that are submitting shares on a pool, and then you get just a percentage of what your share count was of that size of pie. Oh, excuse, what's going on?
You're too high.
Oh. Sorry, I don't know what's going on here.
It's just you're off the screen. They can't see what you're doing.
Sorry. So, does that? I don't know if that helped or hurt. Mechanically understanding how that works. That answer it. Now, I asked a question, which one, and I would say benchmark it, because it's super different on each pool, and if then you can kind of figure out, are they actually paying out? I mean, most pools are pretty transparent. I mean, if they pull so much percentage, they'll say how much they're doing, and then people can, start doing the math to figure out, because it's all transparent. You can figure out how many blocks has been won, what's the division of share, and is their take, their 0.25% or something, is that really happening, or is there more, right? Usually people that put a lot of hash power on a pool will start doing the math to make sure they're not getting screwed, because they're in a lot more deeper from a cost standpoint and operations cost standpoint, and then they'll quickly expose like, hey, dude, you say 1%, but I'm seeing 2.5% come out, and you'll see that usually on the forums. What I would say is on BitcoinTalk.org under altcoins, under pools, those different forums there, you'll see a lot of that, and also just troll the Reddit forums and look and see if pools are not being honest. But I mean, most of them are pretty honest, and it's just benchmarking your particular situation. Any other questions?
Any advice or tips, tricks for Signatum?
No, I don't have a lot on it. I mean, we added it, guys, but I haven't done a lot of time on it. I want to do some more research on it, and look at what the benefits and stuff would be. But I mean, if you're looking at like speed and all that kind of stuff, I mean, I did see that some people were hawking more optimized miners and stuff like that. I mean, and I would just look at community feedback and see if you're going all in, and it makes a benefit for you to want to get the most hash power. You can see people's feedback on it and screenshots and maybe some video to show, hey, here's one miner versus another. We haven't got any of those special miners to say one's better than the other. We've just kind of stayed out of that kind of thing. Just because, I mean, developers, I won't take away from it. Like, we don't turn off the dev fee for like Claymore, right? All of our hash power, all the stuff that's packaged in the multi-miner, it's all built in, right? I mean, because they're doing a service of building it, and there's just a way for them to get a fee built in. Claymore actually lets you take the fee out of the miner, but you take a small hit on hash power as a de-incentivizing effort. You take a 5% hit, he loses 100% of any revenue that he would have made from it. So, it's kind of like what's fair and that kind of stuff. But, yeah. Nothing on Signitum.
Jaxx Wallet. What 1 to 10? How secure do you feel it is, and how do you use it?
I only use the mobile version, and it's got a mnemonic password and a structure to it. It's hyper secure on that piece. There's nobody that's going. They'd have to punch through the OS layer of encryption and then get to it, and then they would still have difficulty trying to get to it on your phone. If you have a rooted phone, a different story, because now essentially it's open, and you could have a different situation there. So on rooted phones, I would say that you've just compromised your phone. While like maybe in like 2006 to jailbreak your phone, that was like a thing, I would highly recommend not doing that anymore. Just because you're compromising the security on your phone. So I'd say from Jaxx, I use it. I've had no problems with it on the mobile. I actually really like it. It functions. I mean, it's kind of quirky and it's buggy sometimes. I have to, like on iOS, I have to close it every time. Like I have to open it, close it, open it up again fresh for it to reconnect. I mean, there's some bugs and stuff with it, but by and large, I really like the coverage that it has with all the different ERC20 coins. I like having Shapeshift built into it because then I can quickly kind of do market trade right there if I want to. You pay a little fee on it, but I've used it several times for like Litecoin purchases. I see Bitcoin kind of at a pretty decent price, and I see Litecoin kind of dip. I'm like, hey, that's a good buy, and then I'll just Shapeshift it right there on the phone. It saves me the trouble of having to go to an exchange and all that, right? So I like it for that reason. And from a security standpoint, as long as your phone's not rooted, I think you're good. I cannot speak to the browser-based one because I don't use it for the browser.
From Bob Saget, one of our bestest fans, he gave us a super chat saying that he would like to see a BBT mining pool. You want to talk about that?
A BBT mining pool. So the ones that we've looked at what it would take to kind of manage and run. And I mean, essentially, like Toad Pool is one that I would say we kind of unofficially endorse. I mean, those guys are in our Discord all the time. Kibbles runs that. And, I interact back and forth with them on the dev side of it just to make sure the pool's maintaining and running and stuff like that. So I wouldn't say it's like an official, unofficial BBT pool. We take nothing from it. I mean, we don't profit or anything from it. It's Kibbles and his effort, but we haven't set up one. I mean, a lot of people have asked us about doing it. I mean, that might be something we get into. Right now, we're just trying to get the channel and stuff organized and try to split the formats out a little bit. You guys have been super generous, especially lately with the affiliate, clicking on the affiliate links and stuff. We're taking that to really kind of expand the content of the channel to kind of start doing more of these, and then maybe have some more researched content to be delivered to you guys to bring some stuff forward. So we'll probably go more heavy content stuff than necessarily going towards a pool, but we are in pretty direct contact with Hold Pool So if you have questions or any of that, go into Discord, throw some questions if you're having problems with it and stuff like that. Kibbles is usually in there to take care of it. I think that it's Expanse. If Blueberry or any of them are in there, they can tell you what all the pools that they support. I believe it's just Expanse and Ubiq. He may have one more other that he's added there, but maybe Music Coin too. I don't know. We'll see if they've covered that. But any other super chats or questions I missed?
I think that's pretty much it.
Cool. Yeah, so coming up this week, we're going to have the BTC BioStar board, the 12 GPU board. We're going to be doing a review with that. We should have 12 cards in for that. So that'll be a 12 card build. We're also going to be doing the, I have a 5 card 750 Ti build. It's kind of a budget build that we'll be doing, and then we're looking at another budget build. A lot of people, I mean a ton of people have asked us for a real cheap kind of like sub $1,500 full mining rig, you know, from cradle to grave. What would that entail? You know, we're probably looking at like 1050 Ti's, but you know, something that's a budget build that has enough flexibility to do multiple different types of coins and have some overhead for some dual mining and stuff. So we're looking at a build to do for that, for guys, people that want to try to get a mining rig for under 1,500 bucks and still participate and all that kind of stuff. So, and that's super efficient on power, you know, and centric. So we're looking at putting that together. We'll definitely have the 12 GPU build for the BioStar board. And then I'm looking at having 2 kind of like we did for the A and AR series motherboard. I'm going to do a deep dive episode review, probably like 5 to 8 minutes at most, on the ASRock 12 or 13 GPU board, and we'll also do it for the BioStar board. So both of those boards, which are kind of like I'd call the standard in mining, we'll do the deep dive review. So that'll show you just quickly and concisely the BIOS setups, and then just the progression to make sure that you can get the 12 GPUs found and working with that. Circumstantially, and hopefully we'll have our new 6-pin risers in also, so you'll kind of get a review of the 6-pin riser, which is actually the 6-pin connector on it. And it has the more caps. It's like I would call it the 8th generation riser that's supposed to have a better, you know, rating. That way they don't keep going out on us. So if there any more questions, we'll start to kind of wrap it up here.
1X Machines, Super Chat. I finally got Digibyte working on the SG miner for my AMD cards on your Mega Miner. Thanks so much.
Nice, yeah. So if you guys see bugs, I seen there's like 3 or 4 bugs that we need to fix on that. On the multi-miner in general, I think there was some issues with number 2. There was the few numbers. So if you guys submit like in comments, say, hey, I was using this and this was bugged out for me. I had to get rid of -G. I think Liam on our Discord had an issue with it. Just submit those in and we'll get those things fixed. I mean, we do try to test it with some of our stuff, but we do miss things. So if you guys see bugs or issues or something that you got working, just send us a note, bitsbetrippin@gmail.com. We'll get that fixed in the next multi-miner. And we're looking at doing the regional adjustment on multi-miner to where you'll have essentially Asia, North America, and Europe kind of selections. So for the folks that are our European brethren and Asian folks out, you know, Japan and just general Asia and general Hong Kong, that kind of area, can have options automatically for the localized pool for that. So for like Nano Pool and Supernova and all that, it'll be those particular sections. It's going to make it a little longer, but at least it'll be geographically selected. So that should help for people that have to keep going in there and editing it. So we got that and a few other fixes. And again, if there's other coins and stuff that you want to see in there, make sure that you guys send it out to us, and we'll try to get those things added for you guys. So if that's all the questions, we'll go ahead and wrap this one up. And if we can, we'll try to get one out tomorrow for you guys, if we can put that 750 Ti rig together in time, because I do have everything I need for that here. Otherwise, we'll have a few next week, and you guys stay tuned. Be cool. Check us out on Steam it, and if you haven't seen it, we'll have it posted down in the description. You guys go out there, make an account out there. You can upvote and do things out there and give us feedback. All right? Stay tuned.